All right. Mercy, what about number 2? What are the 2 categories of work that you found?
The work done against another force and the work done to change the speed of an object.
Okay, good. So work done against. You said work done against a force?
Yeah.
Okay. And the other thing you said, work done to change speed. Okay, and where'd you find that, Mercy?
In the back.
Okay.
The beginning of the first paragraph and the beginning of the second paragraph.
Good. So work falls into 2 categories. One of these is work done against another force. All right, excellent. And the other one you said is work done to change the speed. I'm going to give that a 4 also, because they're both they both answer that question. Okay, so which does more work? Superman holding a bus over his head, or Mr. Rohrback lifting a half-pound dumbbell over his head, which, by the way, is the most he can lift. We tested it the other day. We wanted to make sure that this problem was as accurate as possible. So, Evan, what did you say for that one? Which one is doing more work?
Is it the dumbbell because you're actually lifting it?
Bingo, yes. I know Superman is exerting more effort, but he is not doing more work. Work is force applied by a distance, and so this one is going to be Mr. Rohrback. Okay, and that's because he moves the distance. Okay? And again, that just kind of comes back to our definition, force times a distance, right? So force times a distance, he has to be moving at a distance. You might have had different evidence, but I'm going to cite this one again. Because you have to have a distance traveled in order to have work done. All right, when you're climbing stairs, what category of work are you doing? Matthew Palmer, let's see, we'll start with you. What do you think? What category of work are you doing when you're climbing stairs? Okay, so it is traveling a distance, you're right. So first of all, it is doing work, which is a good thing to establish. It is going to be doing work. Rhea, what do you think? What category of work is it doing when we're climbing stairs? Yes, this is work against another force. And Rhea, how do you know it's work against another force? Yeah. When you climb stairs, you're not speeding up or slowing down. Generally, maybe you are. But in generally, you're not speeding up or slowing down. What you're doing is you're doing work against another force. And that other force is gravity. We're doing work against gravity. We're going to do this for our lab. We're going to do work against gravity, and we're going to use it as a good starting point for solving work and figuring out what work is and what happens and what causes it and that sort of thing. All right. Nope. All right, Erica, what about number 5? When you kick a soccer ball, what category of work is this? Good. This is changing speed. Okay, and this is also a number 4 thing. Okay, now we get to the good questions. So I'm going to have you get back in your groups again for those of you who moved. I'm going to have you move back. I'm going to have you guys do these next 3 together. I'm going to have you do these next 3 together. Which is, what would happen if you applied negative 10 joules of work to an object? So a moving object. So this is going to be a changing speed example. If you did negative 10 joules, what do you think is going to happen? Describe it, and then tell me where in the reading you think you got your idea for this. Okay? Give me a sec. Number 7, does gravity on the Earth do work on the moon? You should explain your answer. I think that goes without saying. But in case you try to weasel out of it, you need to explain your answer. And lastly, in the last unit, we explained cushioning using impulse. Can you explain cushioning using work? Yes, you can. I want you to do it. Okay? I want you to see if you can explain cushioning using work. Here, if you're having trouble wrapping your mind around what I'm asking, when you dropped an egg on a pillow, we said the reason we could say the pillow was soft is because soft objects have a longer time interval. Can you, instead of explaining long time interval, can you explain how it would work with distance, with work? Okay? A soft pillow versus a hard table. Again, both work and impulse have force, so you can use that kind of as a starting point. But go ahead and answer those 3 questions, 6, 7, and 8. Okay, what would happen to an object if negative 10 joules is done on it? All right, let's see. Joshua, what do you think? If negative 10 joules of work is done on something, what do you think is going to happen to it? Yes, it will slow down. Okay? A moving object, it is going to slow down if you do negative 10 joules of work. Joshua, what makes you say that? Yeah, you said to change the speed. Is that what you're saying? Yeah. So if you have negative, it'll change its speed in the opposite direction. Perfect. So negative means opposite, okay, which is going to slow. Yes, negative 10 joules of work will slow an object down. Perfect. Okay, and again, make sure for your answer you cite where you think you're getting that from. So he's kind of explaining it with terms of that second category of work. All right, this is one of my favorite ones. I love this one. I can't wait to see how many people have each answer. Just quick raise of hands. How many people think that gravity does work on the moon? Nice. How many people think it doesn't? Ooh. Oh, this is fun. Okay, good. Let's see why we think it is, and then I'll play devil's advocate, and we'll see. We'll see who's right. So, Sebastian, what do you think? Why do you say that the gravity does work on the moon?
The reason why I say that, I was actually looking at the first paragraph towards the bottom.
Yeah.
When it gives the pusher example, the sentence before that actually says that work is used to raise an object against the force of gravity.
Okay, good. So this is, where is it talking about lift of gravel, right? Is that what we were talking about? Huh? Ah. So you're looking at, oh man, I used 2 different colors. Oh gosh, that's a disaster. So you're saying, good. So work is required to raise the ram against the force of gravity. Good. All right. Makes sense to me. Anyone got different evidence or a different idea? Okay, I'm going to play devil's advocate. Gravity doesn't move the moon a distance. It can't do work if it doesn't move the moon a distance. Okay, come at me, bro. What you got? Yes.
How does it orbit?
Ooh, good question. It orbits because of inertia, not because of gravity. I'm just playing devil's. I'm not saying I'm right. I'm just being a pain. Yeah.
Isn't the Earth have like gravitational pull or something?
Yeah. So Earth creates a gravitational field around it, and that pulls on the moon, and that creates a centripetal force, kind of what we talked about a couple units ago. So there absolutely is a force on the Earth, or by the Earth. The correct answer is. Drum roll. Thank you. I'm right. And the reason I'm right is exactly what I said. The Earth, gravity does not make the moon move. Gravity keeps it from going out in a straight line. But gravity does not make the moon move. Moon moves because it was already moving. So therefore, the Earth doesn't do any work. Now you're saying to yourself, but the moon does move a distance. Yeah, but the equation is work equals force times distance. This is the distance because of the force. Gravity is not why the moon moves. The moon moves because it was already moving. I love this question because it's super funky. It's also very literal on the definition, but this is true. Gravity does not do work on the moon. Yes?
But if you roll the ball,
yes.
It eventually stops, so why doesn't it do that?
So, that's because of what? What force stops it?
Friction.
Yes. Friction is in the same direction as the ball. So friction is acting on the distance, right? The distance it's traveling is partly because of friction, because friction is slowing it down. So while friction is not necessarily responsible for getting it started, it is responsible for it stopping. Whereas gravity is not responsible for the orbit and the path it travels. It's responsible for holding on to the moon. That's a great example, though. Yeah?
I have a question.
Yes?
Does the moon have energy already?
Ooh, that is a great question. I like that one. Does it have energy? It depends on how you're wording your problem. The answer is yes, because it has motion and there's motion energy. But there's another type of energy which would be stored energy, and that depends on how you're looking at the problem. But to answer your question simply, yes, it does. Yes.
The Earth is not making it change energy.
Ooh, I like it. Yes, you're exactly right. The Earth is not making it change energy. Ooh, look at that. You even gave a better definition than I did, Mercy. I love it. Mercy's using this here. Work is the effort exerted that will change its energy. I'm even going to put it in there because I'm so proud of that definition. She's using the definition of work, the effort exerted to change its energy. Earth does not exert any force to change the moon's energy. The moon's energy is what it is. It doesn't change. Ooh, I like that. I like that. That's good, Mercy. All right. Someone else. Yes, Sebastian.
I was going to ask, in that sense, did the moon initially have force?
Ooh.
It collided and then a chunk of the Earth broke off and then
Well, first of all, hold on. Hold your horses. It depends on how you think the moon formed. There's lots of different... Actually, there's 4 theories on how the moon formed. One of them is what you're saying, is a chunk broke off. But there's 3 others besides that one. The moon had energy because the solar system was created. The solar system, as the gravity caused the solar system to collapse, as it collapsed, it caused it to spin. Kind of like when you pull the plug on a drain, the water starts to spin. It's the same idea as that. So that's where the motion came from. It came from the formation of the solar system. Good. Awesome questions or things. Yes?
Slightly similar logic, I guess.
Yeah.
Does the sun exert work on the moon?
Cushioning using impulse. Can you do it using work instead? Specifically, think about distance. Let's see. Who we want to pick on a lot of people there. Let's see. Luke, what do you think? How can we use work instead of impulse?
I put an impulse, the cushion slows it down. I put similarly the work the cushion and work ordering the object.
Yeah, just instead of thinking of doing it over a time interval, we're talking about doing it over a distance instead. Softer objects have a larger distance. Whereas harder objects have a shorter distance. Just like